Hello, and welcome to the Did You Get It for lesson 2.7. These are going to be supplemental problems that are in the workbook that are going to help you with your understanding of the content. So the Did You Get It from this lesson refer to this example that you should have watched in the videos about the bouncing ball. Now, we did not do this one in class in the workbook, so I'm just going to go over it. The students are going to mark a ball, and then they're going to be dropping the ball and bouncing it and seeing how far the ball bounces up and down. And so they would have done that, the bounce of the heights here, and then they would have gotten an average height of their different trials. Okay, and then they would have graphed it. And you do not need to have done that problem to be able to work on these Did You Get It? So Did You Get It number 1 is on page 228. You can turn there. So it is saying, when trying this experiment at my campus, I got this following model: 263 times 0.84 to the x. What was the approximate height I dropped the ball from originally? And so we have to remember that in an exponential equation, an exponential model, the parameters, the two things that give us our directions are A and B. And A is your rate. This is your y-intercept. And B is your rate of change. And your y-intercept is your starting value. So for us, 263 would have been the original height. And they measured these in centimeters. About how high was the 7th bounce? So the 7th bounce is going to be x equals 7. So when x equals 7, and we can remember this is function form, and function form means that I'm just going to note this right here. So when the reader looks at my equation and they see f of 7, that means I put 7 in for x. So it's going to look something like this. So I replace x with 7. And then when I go to Desmos, I can put my equation in here if I want to look at the equation. But if I just want to copy the basic of the equation and then just replace x with 7, I can find out that when x is 7 on the 7th bounce, we are predicting that it would be about 77.61 centimeters. Also, as you're working through Desmos and any of these problems, it's always good to make sure you're logged into Desmos and that you go over to the top left and you hit save. And I'm gonna do L27 for lesson 2.7. And then I'm going to just say, did you get it? So I will reference these as the did you get it? And so this is what I'm working on there. So now let's go back to my paper. And you can see, I'll get it in the 2 at the bottom, says, look back at the bounce height function that we just used. What is the significance of the 0.84 in that function? What does it tell you about the difference between my golf ball experiment and yours? Okay, so 0.84 here, we said up here is our B, and B is the rate of change. So that is here. B is equal to 0.84. And remember in lesson 2.5 and 2.6, we worked on representing that if you take B minus 1, because B is our multiplier, but B minus 1 is called our rate of growth or decay. And because, let's go up here and write this here. because B is equal to 0.84 and it's less than 1, it tells us it's decay. And so if we take B minus 1, which is 0.84 minus 1, we get 0.16 negative, which tells us, if we put that in percentage, that we are decaying. The height of the ball is going down by 16% each bounce. And so I'm going to write that down here for you. Because it's negative, it means it's decreasing. The height of the ball is decreasing by 16% because it's negative 0.16. The negative tells us it's decreasing, and the 0.16 in percentage form with each bounce. So again, when your B, your multiplier, is less than 1, it's a decay. And if you take B and you subtract 1, always take B and subtract 1, no matter what number B is, then the value, if it's negative, tells us that it's decreasing, and that would also indicate decay. So let's move on to, did you get it, number 3 on page 231. So it says, recall that our function that I came up with is here. What should the relative change in bounce heights work out to be? In other words, if I'd made a table comparing the drop height to the bounce height, like in question 9, what should I have gotten for the average relative change? And then I said it was going to be a negative 16%. We already calculated that. If my experiment had worked out ideally with perfectly consistent bounces and completely accurate measurements, what would I have gotten for the equation of the line of best fit for the data comparing drop heights to bounce heights? And we're not going to do this because we did not do this one. We don't actually have data for this one. We didn't do it in class. And that concludes the help for the Did You Get It in lesson 2-7.